Hello and welcome everybody to C++ 101 Week 5. I'll be here and I'm Nelson and so will Gavin. Hey Gavin.
Hello.
Hey.
Man, you said that in a very deliberate fashion. It was almost as if you'd done it a couple of times and got it wrong.
Yeah. No, I've never messed up a recording before.
No, of course.
Never. Okay, today we're going to be covering up just some really loose end sort of things that's going to bring us or get us up to speed to where we need to be on week 6 and week 7, where we're going to be going over some more complicated things. So today we're going to be talking about enumerations, structures, simple file input and output, array of structures, and the vector class. So yes,
dun, dun, dun.
Super exciting. I'm going to go ahead and pause the video. Okay, so let's go ahead and get Visual Studio up and running. I'm going to go ahead and create a new project.
Have you unpaused yet?
Yes, I have unpaused.
Cool. Don't say it as if there was never any possibility of you not having done so.
That's never happened either. Hopefully at this point there should be no problems understanding this code. What we're going to be talking about first are enums, or enumerations. An enumeration is a kind of type that we can create. We can create our own types in C++. So just as int and bool and floats, those are all types. std string is a type. The ostream and istream types are types. We can create our own types in C++, which allows us to create reusable bits of functionality that we can, well, reuse across multiple bits of our code. The first custom type that we're going to be talking about are enums. And enums have no correlation to enumerables or other sorts of things that have the word enumeration in them in other languages or platforms. They really are a separate concept from a collection of things. So don't get the terminology mixed up. In addition, enums behave differently in C++ compared to Java or C#. So,
in what way?
Well, in many ways. If you're coming from Java, you might be it might be sad for you to hear that you can't add methods to enums. In addition, enums have some implicit conversions that we're going to be talking about that don't exist in C+ or C#. So I'm going to go ahead and build up a example. I'm going to say int current menu equals 0, and I'm going to say while true, switch on current menu. So I'm basically going to create a nice little state machine that'll allow me to have a nice little program. I'm actually not going to do this because I typically don't do this in the first place. If input equals 1, no, if equals 1, then current menu equals 1, and blah, blah, blah. Again, because I'm working with integers here, I could make things a little bit shorter, but I'm not going to, because we're going to be talking about how relating input with behind-the-scenes concepts such as what current menu we're on, it shouldn't typically be done, as it creates flexibility and robustness limitations of your code. So then I'm going to go ahead and say cout new game menu, and then I'm just going to cin input, and I'll say, if input equals 0, then we're going to go back to the main menu, and then I'm going to do this for the load game and the save game as well. So we're going to have 2 and 3. We're going to have load and save. So basically what I have here is a really simple program, and this is a very common pattern in programming where I've created this nice little state machine. So it kind of follows the state machine pattern in a very procedural way, but you can conceptualize what you see here in terms of states. We have 4 states, and the states are represented by an integer variable that decides which state is going to be printed on every iteration of this infinite while loop. And you'll notice certain states allow us to transition to different states. So we have our main menu that allows us to transition into the new game, load game, and save game states by simply providing a bit of specific input to the program. So if I were to run this, we'll notice that I get my main menu, and I can switch to the load game state by typing in 2. So now I'm in the load game menu, and I could probably do better on the prompt there. So I can say load game menu, and then I can type in 0 to get back into the, load game, 0 goes into save game. Am I stupid? Oh. Here's one of the reasons why I don't like switch statements in C++. In C#, these switch statements would error out if I didn't have a break there. You can have multiple cases assigned to one specific block in C#, but you don't have the falling through behavior that you just saw me wrestle with. So now that I've fixed the code by adding in the appropriate breaks, I can run the code again, and you'll notice that it behaves just like you'd expect it to. To the load game menu, I can type in 0 to go back to the main menu. I can jump into the save game menu, and I can continue to be in the save game menu, then of course break the input because of the stuff I typed in. But we can go back to the main menu, load menu, go back to the main menu, new game, go back to the new game menu. Are there any questions about this code? It's very, very straightforward, very common pattern of code that you will be doing quite often, especially in console-type applications. Do you guys have any questions about this code? Again, I haven't introduced anything new yet, but we're going to be talking about why this code kind of sucks and how to fix it. Oh yeah, I forgot. Everybody's asleep on Fridays.
That's why it's a shorter class.
Why use switch statements over a bunch of if-else statements?
Because switch statements are great.
Eh.
Well, no, see, in this particular case, switch statements are ideal. What you have here is you've got a finite number of choices at each stage. You know, that you can choose 0, 1, 2, or 3. Those are your options. And in that case, a switch is ideal, because you're not expecting, oh wow, I've completely lost track of that sentence in the middle of it, but Nelson knows what I mean.
Yeah. Well, yeah. And I could turn this into a switch statement as well. I could say switch on input, case 1, current menu equals, blah, 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 1, case 2, case 3, and there's no 4. 2, 3. And it would help if I did this, and it would also help if I did this. Okay. So the reason this code really sucks is because we are talking about states in terms of integer values. And there's a variety of issues with this. First of all, you'll notice that we have to constantly re-specify magic numbers every time we want to reference a state. So on case 0, we have to reference the magic number 0, which we magically know corresponds to main menu. Just as when we switch back to the main menu state on these 3 if statements, you'll notice that we also have to repeat that 0. So that's problem number 1. So let's go ahead and address problem number 1 first. We can do so with a variety of tools that we've already learned. I can say define main menu state 0, define new game state 1, define load game state 2. Now we could do this. However, I would very, very much discourage the use of defines for constants. A lot of it's just not good.
Is that just primarily a question of sort of code safety, really?
Yeah, it's about code safety. It's about this is not the appropriate construct to define constants with in C++. The appropriate construct to define constants is via the const modifier, which we can easily do as well. We can say const int main menu state equals 0. And this would be a more appropriate solution. Because with the primary difference is that our constants carry with them a type, which allows the constants, well, I mean, of course, everybody already knows that C++ is very liberal as far as typing, but in this case, we do have some level of type safety by associating our values with a particular type, instead of simply defining a search and replace statement, more or less. So you'll really want to use constants in your code. In addition, where you use constants is more limited to where you use defines. A define can be referenced anywhere in your application, because a define is handled by the preprocessor. The preprocessor takes this instruction and uses it to literally copy and paste any code it sees. Or not copy and paste, but search and replace for any bits of that it sees. And that's all at the preprocessor level. Meaning it's not at the compiler level, it doesn't have the information that the compiler has. So by instead associating your constants with something that's computed by the compiler can enforce more constraints on where it's appropriate to place these identifiers, which will help with finding bugs and potential strange behaviors. Okay.
And Justin did ask, if they're outside of main, those are global variables, correct? And can be used anywhere in any .cpp?
Constants are going to be, they're not global variables. A constant is not a variable. In fact, the words constant and the words variable are antonyms as far as the English definition goes. And a constant isn't a variable. It is instructing the compiler to replace any instance where this identifier is located with this value. Now, it's not just being dumb about it. It's not like a define, which is literally saying whenever you see this text, insert this text. No, constants are whenever you see this identifier, replace it with this value and carry the type information along with it. They're not variables. And
no, the global, I think, was the part that he was asking about, though.
Right, and they're not going to be global either. That's because they're not variables. They're not really, the linker doesn't care about them. Meaning that if you wanted these constants to be globally accessible from any CPP file, it would be appropriate to place these constant values within a .h file, within a header file, and then include that header file anytime that you want to use the constants. By defining them in here, they're not automatically accessible from other CPP files. We would instead have to create a header file to store them in. Does that make sense?
Mm-hmm. So, is there a way that we could make these constants easier to notate?
Well, yeah. I mean, I'll go ahead and show the problems that we'll encounter by fixing this one issue. We have successfully fixed this one issue, but we still have another issue that we're going to be talking about.
Hurrah! Boo. No, line 23 is wrong, I think.
Wait a second, I don't have a save game state, do I? I'm really bad at this game. Blah, blah, blah.
Line 24, actually, sorry, not 23. 24 is wrong.
Yes, it is. That should be, 1 should be new game menu, 2 should be, blah, 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 blah. See, I totally forgot. Save game menu, or save state, new game, load game. So 3 should be save game, 2 should be load game.
Wow.
So, now that everybody got to see me fail, again, let's verify that the code works as we expect it to. Okay, so we fixed a problem. we now have associated some meaning to each one of these constant values, and have made our it made our code just significantly more palatable, because we can now quickly identify what's going on, what the intent of the developer was, especially between lines 24 and 26, and also within the case statements themselves. But we still do have a problem. And the problem is that our current menu is not a number. And it is. We're representing
it's a human being.
Our menu state is not a number. It's not any piece of data. Well, it is a piece of data, but it's not any piece of data that can have arithmetic operations performed on it. It doesn't make sense to add a new game state to a load game state. That's silly. Conceptually, our main menu, or our current menu, has really no correlation to an integer and shouldn't be treated as an integer. And as a result, you'll notice that our state, our variable, carries, in addition to the fact that it is an integer, which it shouldn't be, because an integer applies that it's valid to perform arithmetic operations on its value. You'll also notice that by looking at line 11, if these constants weren't defined immediately above main, looking at line 11 does not in any way tell the developer that might be reading this code what the valid range of values in the current menu are. It doesn't speak to you at all. It doesn't indicate what the valid values are. And as a result, you might be looking at this integer and think, well, I can stuff anything from negative 2 billion to 2 billion in this integer. I'm going to go ahead and do it and end up breaking the rest of the program, because it doesn't constrain anything.
On that particular line, would you see, and again, this is another problem with it, would you not really want to be,
But it's still, though, it doesn't, the type of the current menu doesn't in any way...
Oh, no, I'm not disagreeing with you, but it suddenly struck me then that...
And in addition, think about this. Let's say we have a void print menu method, and it takes in a currently selected menu. Can anybody tell me how, in any way, a developer who only sees this prototype, or not this prototype, this signature, can anybody tell me how a developer would know what the acceptable range of values that this integer menu variable or parameter should take in? And the answer is no.
The answer is no. Yeah. Well, I mean, if you, and for anyone who isn't, I mean, you'll be gathering by the length and tone of the discussion that this is a bad thing. But if you want a more obvious example, Nelson, we also need the ability to delete save games, and we need the ability to exit the game. Can I have some more options on main, please?
Right. It's a matter of, in addition, you'd have to add some new constants.
Oh, go ahead.
So you would have, what are we doing again?
Work. Delete game. And exit game.
So you'll notice, first of all, I had to do two things when copying and pasting that. And I do want to point out, though, it's to somebody in BuzzNet, they said, well, why don't you add a comment or documentation to print menu? Notice what I just did. I just added two acceptable values for the int menu parameter. If I were to have represented this inside of a documentation on top of this function, I would have to update the documentation every time that I added a new constant.
And the idea of adding documentation rather than making your code clear in the first place
is preposterous.
Documentation should be supplementary. It shouldn't be a replacement for clarity.
Right.
Anyway, carry on with your heavy workload that I've just caused for you.
Well, in this case, so then we would go ahead and add in, a few additional states. Well. exit. That's what I called it. And then we would have to add some more input handling logic.
And hopefully you can see already that, I mean, this is a very straightforward one code file, well, one method really, and already there's an awful lot of work to do just to get 2 more options available. Oh, there's more work to do still. And every one of these points is a point for somebody to introduce an error, and it's a chance for something to get missed or something to get typed wrong or in the wrong order. And as you know, with C++, you don't have the security blanket of good IntelliSense.
Right. Yeah, the IntelliSense pretty much just sucks. Anyway, so yeah, and as a result, it's all about, at least as far as the proper constraints of a type that you have, by allowing yourself to place in any valid number, any valid integer, negative or positive. You run into a situation where people reading your code or writing code for your system or modifying your code don't have really any semantic value as to what the valid ranges of this particular integer should be. So what we can do here is, that's really the final problem that we have to address. We really do not want whenever we represent a menu state, we really want to create our own custom type that constrains the values that we can legally place in them. And to do so, we have the enum type. The enum type, like most constructs in the C++ language, is a keyword followed by an identifier followed by a bunch of curly braces. So for example, I can say enum menu state and create my enum. So you'll notice a few things about this type. First of all, this is a type. This type does not represent any executable code. Enums are just, in a way to sort of constrain the acceptable values, the acceptable integral values for an integral type. So in this case, what we have here is a definition, and inside of the definition of our enum, we can place valid values for the enum. And what I'm going to do is I'm going to just type in main menu new game load game save game delete game exit game. So you'll notice some interesting things. When I hover over each one of these identifiers, and again, these are identifiers separated by commas, you'll notice that each one of these identifiers has an integral value. So we have main menu being 0 while exit game equals 5. You'll notice that they increment. They start at 0 and they increment. So what's going on here is we have essentially created a data type that has only these valid values. That's it. These values have no relationship to each other. We have a set of valid values. If you think about it conceptually, they are their own distinct numbers. So for example, we might have our, we count 1, 2, 3, 4, 5, 6 into infinity. That's a set of numbers. You can represent that by saying this is a set of numbers. Now, take your concept of numbers, 0 to infinity or negative infinity to infinity, and take that set and completely remove it from your mind and create a new set. And that's what we have just done. We have created a set of valid values for a particular type.
I'm going to do a Jason here. Another way to think of this, in the nightclub that your menus are trying to be, that you're trying to get into, the enum's your bouncer. If your name's not on the list, you're not coming in. This is a list of acceptable values for this, and if you're not one of those values, 6 comes along, he's got the wrong shoes on, he is not coming in. Continue.
Alrighty. So now I can delete my constants. And you'll notice a few really important things happen as I'm going to modify this code to take advantage of the enum. Instead of saying int menu, I'm going to say menu state menu. I have now answered the question from before. If a developer looks at this method and says, okay, what are the valid range of values I can provide to this parameter? Well, it's taking a menu state. What's that? Right-click, go to definition. And you jump to the definition of the enum. Now the developer has, I guess you could say documentation,
Well,
although it's not executable code, but it's code that is specifying exactly what you would have to specify otherwise in printed documentation.
and over and above that, you could quite simply just type menu state dot now at line. You wouldn't even have, because assuming that the menu state wasn't necessarily in the same code file.
Kind of. You can with the Visual C++ compiler, but not, or the Visual C++ IntelliSense, but this won't be cross-platform. Because this isn't how enums actually work in standard C++.
Okay, well.
But you can inside of this, because...
That's me told for being a Microsoft user.
Segfault, we'll get to that later. Sorry to ask another global question, but would that enum set be considered global and accessible outside of the CPP? No. Nope. Enums are not cared about by the linker. The linker doesn't care about enums. The compiler cares about enums, and the compiler is going to replace... it's going to use enums for two purposes. It's going to be used to validate the type safety of code, and it's going to be used to replace anytime any of these enum members are referenced with a corresponding constant value. Meaning the linker, again, is not in any way associated with putting enums together. And because the linker is not involved, if you were to place this enum into a .h file, you could just include it in on CPP files, and that's how you would do it. You would stick this enum up in a .h file, in a header file, and then in other CPP files you'd pound include it. Okay, I do want to point out some important things though. This. Semicolon is very important. We'll go over the reasons why the semicolon exists in a little bit. Okay, so we've solved our problem with print menu. We now have menu state menu, which leads the developer to the acceptable values for this parameter. Now in int main, you'll notice that we have some errors. First of all, this constant no longer exists, but this constant does. You'll notice that I just type in main menu. This corresponds to this enum member. Enum members are treated just like constants and do not need to be prefixed by the enum that they're a member of, which in my opinion is really, really awful, but we'll go over...
Bad idea.
You what?
Bad, yeah.
Yeah, I think that's really gross. I think it clutters up the global namespace, but we will be talking about ways around this later. Okay, so now you'll notice that what we can do now is say not that current menu is no longer an int. Current menu is a menu state. So that's also very important for the readability of your code. This code is instantly considerably more readable and comprehensible by other developers now that we've declared that this type may, or this variable may only have a very specific set of values in it. So now we can modify our switch statement. So instead of main menu state, we'll just do main menu. Instead of new game state, we'll do new game. Load game state becomes load game. Save game state becomes save game. Delete game state becomes delete game.
You could just delete the state.
Yeah.
Cracks me up. It's, you know, it just seems a little easier.
Okay. So what we've done is we've solved a variety of problems with our code. And as a result, we no longer have any magic numbers. Now you might be saying, oop-de-derp, these are magic numbers. They are and they aren't at the same time. The reason that I'm not replacing these with the enum is because these numbers correspond to what I printed out in the user interface.
And actually,
You what?
yeah, I was going to say there's no reason that they need to be integers anymore.
Yeah, they can be strings.
They could, yes, but yeah, but the point being they are directly correlated to the input. At some point, you have to specify.
Yeah.
At some point, you have to specify what the user inputs and how it relates to the rest of your code, and this is the logical place to do that.
Right. Basically, I'm presenting the user with the user interface and translating the user intent into an instruction that's specific to my program. So, as a result, you'll notice I am not using the enum values. Even though the enum values are technically numbers, the fact is numbers are not supposed to correlate with enumeration values in a typical sense. Now, there are some situations where using the enum syntax is easier and faster and looks nicer than using constant syntax when you are defining a wide range of constants, perhaps for use with interoperability with other platforms or OS level stuff. But those situations aren't the norm. Typically, an enum should be conceptualized by a entirely new numbering system, an entirely new set of valid values for a particular type. They should not be treated like numbers. And conceptually, there is no correlation between my input and the menu state. That's just like saying, yes, new game is set to 1. There is an implicit correlation, but saying that these two, the input and the state I transition to, are conceptually similar is like saying, I don't know, something that isn't similar is similar to something that isn't similar to what the other thing is. It's just not.
Wow.
It's really not. Okay, what size is the enum type? The enum type, it always has a backing type. So basically, by default, we're going to be backed by an int. And what I've done here is I've explicitly defined my backing type. The enum type is backed by another type, by an integral type. And that means that this enum will be of that size of whatever type is backing it. Now, in this case, I could get away with doing a char. What this does is now menu state is a single byte instead of 4 bytes. And I can make it a single byte because I'm not placing more values than a character can uniquely represent.
So,
Bando, was that at me? Or how is main menu equal character? A character, remember in C++, a character literal is an integer value. That's all it is.
That's practically everything else.
Yeah.
Far too many things are.
A character type is an integral value as well. So you'll notice I can say char b equals 43. A character type is typically going to be 1 byte wide, meaning it can store the values. In this case, I believe this is going to be a signed character, which is -127 to 127. But yeah, it's not that the main menu equals a character. It's that all a character is a single byte number, and main menu is being stored in a single byte number.
Yes, if you printed out B there, it would be a plus sign.
Okay. Yeah. In certain languages, that's not possible. Just like in certain languages, that isn't possible either. And you'll notice it gets typed to a nice little integer.
improperly thought out languages.
Yeah.
That isn't possible. It hurts my brain.
Okay, any questions about enumerations? Because we're about to get into some funkiness with enums at a very just a syntax level, just to explain why this semicolon is needed. And I just want to do this based off completeness, but if people still are having some difficulties with the enumeration concept, please say something.
Yeah, this class, either everyone's grasping things very quickly in this class, or everyone's incredibly shy in this class.
Yeah.
If you have questions, put them in the questions panel. No one else can see them apart from the staff anyway. And it's the only way that we know that you haven't understood. Because otherwise, if there's no questions, we have to assume that Nelson's teaching is immaculate.
Is enum similar to an array? No. An enum is going to be a type that we can repeatedly redefine. So, for example, this is not executable code. This is code that is literally a definition of something. It is an instruction to the compiler, not an instruction to the CPU. And it's a definition. It's not executable code. It's nothing that's going to consume memory at runtime. It's nothing that's going to waste CPU cycles at runtime. It's just a definition to the compiler specifying that whenever it tells the compiler, whenever you see somebody trying to make a variable out of menu state, instead of letting them just do whatever they want with that variable, I want you to enforce as the compiler that whatever value they place into a variable typed to menu state is one of these values that I specified. No, you can't fill an enum at runtime.
There appears to still be some confusion over the issue of, the memory allocation and what happens if you don't cast it as a char.
The default memory allocation is going to be 4 bytes because by default it's backed by an integer.
And there's one question. I'm not sure why using case new game isn't as good as using case 1. In the switch, I assume it means 33 through 37. And it's not so much that it's not as good. It's just that it's inappropriate there.
Yeah, it's if you were reading this code and you saw people throwing magic constants around, you would have no idea what was going on.
The case 1 on line 33, the 1 relates to the one that the user has to input. If you just show the if you just run it again a second, Nelson.
This 1 does not correlate to my enumeration. This 1 is there because it's defined to be there by the designer of the user interface. It's not correlated to my main menu. This code actually performs the logic that correlates the design of my user input or my user interface to an internal representation of the user's intent.
So, for instance, you could quite easily be,
new game could be 5.
Chicken, cow. Well, no, not even that. Just, turn it into something that isn't numbers.
Well, I can do strings.
Yeah, it's just, or chars. You can make them chars. A, B, C, D, E.
Yeah, that'd be better.
Be easier.
Okay, so new game is N, load game is L, save game is S, delete game is D, quit game is Q.
N, L, S. D, Q.
So now what I've done here is because I was in no way, because the user input is in no way correlated to my user interface, it gives me the flexibility of altering my user interface to anything that I desire. And then on lines between lines 34 and 38 is where I write the code that takes the intent of the user that was passed to the interface and converts it to the intent of the user in a way that's understandable to the rest of the program. Okay. Is there a way to see what equivalent integer value of a state? At compile time, you simply need to mouse over them. So new game is 1, load game is 2, save game is 3. At runtime, you can do this. You can say cout current state, current menu, new line. Or, sorry, that's this is the one great thing about C++. What?
I was going to say, what output does that give? Because I would look at that coming from C# and expect to see
A string.
an integer.
Right. Well, in C++, you must explicitly cast. In this case, I'm going to cast it to a character. You must explicitly cast enumeration values. So now you'll see current state is 0. Well, oh great. It was interpreting that as a character. So current state is 0, and I do n, current state is 1. Now I can type in 0, current state is 0, d, current state is 4, and so on. You can do this, but this has limited usefulness, very limited usefulness, because it really does sort of break the entire conceptual integrity of an enumeration by taking a value of an enumeration, which is supposed to be a set of numbers, or a set not of numbers, but a set of things that have no relationship to numbers, and you're shoehorning it into a different numbering system that shouldn't be treated in the same way.
That's the first small step on the path to doing delete game plus exit game divided by current menu, which has actually got me thinking some cool ideas. But, yeah. Anyway, sorry, carry on.
Okay, so that's a way that you can see the numerical value of an enum if you wish. Okay, so
Cool.
Any more questions about enums? Because I'm about to explain this little semicolon, and it's going to be very... the syntax is going to get very funky very quickly.
Wow, wow. Sorry, I was getting funky too soon.
Okay, this semicolon is here because in C, you did not need to name your types. In fact, you couldn't name your types. You could type def your types, but that's different. By default, you couldn't name a type. Instead, what you would do is you would type def this into something else, and it would become very confusing very quickly. I'm probably missing a parenthesis or something in that state. Okay, so what is a type in C++? Well, a type is really you're naming a type right here. Menu state, current menu. Menu state is a named type. It's a type that you can repeatedly refer to throughout your program. But really, all that does is that creates the type inline right before the variable. So, for example, I can create an enum right in here. Let's call this,
Gerald.
Not started. Found number. Found dot.
Found Gerald?
No Gerald. Okay. What I've just done is I've shown an example of using a named type, the menu state, and I've also shown an example of an anonymous type that would be what you would see most often in using C. But what I'm doing here is I'm actually creating, instead of giving a name of a type for the type of the variable, I'm providing the definition of the type inline. This is why the semicolon is needed. The semicolon, anything after the semicolon is going to create a variable of the type you were just defining.
Sorry, say that again. Anything after?
Any identifier afterwards. So I could say current menu equals
But
main
before
menu,
the semicolon.
before the semicolon. And that will create a global current menu variable of type this and assign it to main menu. So this is true for enums, classes, and structures in C++. So it's really important to not only never forget the semicolon, but also to understand why it's there, because it allows us to actually do some fun stuff later on in Not 101. But I just wanted to, for the sake of completeness, I find the syntax very intriguing myself, because it's not something you would typically see, but this is why the semicolon is needed, because generally speaking, before people came to their senses and C was still predominantly used and C++ hadn't been invented yet, you weren't allowed to name your types in a coherent way. You could still name your types, it was just the syntax looked really ugly. Using the line on line 21 would leave you with only the one instance of the enum variable, and you'd have to type it in again each time you want to use it, whereas the named enum allows multiple instances. Yes? So I really wanted to give a basic example of when I would use this. This is where I would use this. Let's say I have a function that parses for float values, and the parser has three states. It has a not started state, a found number state, and a found dot state. And by using the state machine, we can quickly and very easily validate dotted numbers, because we can track if we haven't started parsing yet, if we've started eating numbers, or if we found a dot, all with one single type, one single variable. So here's an instance where I would use it. Basically a three-way Boolean is what I'm using it for. So I just wanted to point out that, and then if I wanted to go really crazy, I could do, instead of defining menu state up there, I could delete this. I could say that, and this would be, valid C++ code. Although in this case, this is particularly ugly. I don't like this syntax very much. When you have such a large enumeration that is useful elsewhere, I would typically not inline that into a function, because that's kind of stupid.
Have you actually shown the sort of error that you get if you do miss that semicolon off?
Yeah.
Just to give people an idea of sort of if they see the error, oh, that might be that. Because, in fact, you got a proper error.
Yeah, we said that. Yeah, on Monday it was the same thing. It was like,
I was expecting gibberish.
Oh, same here, because I think this is probably a new addition to the compiler, because I remember being bit by the missing semi for a very long time, and it irritated me. Can you specify the values in the enum? For instance, I want -1 to be assigned to not started. Yes, you can if you wish, but be aware of problems. If I specify not started as -1, not started becomes -1. Found number becomes 0, and found dot becomes 1. So we can do this. Be careful. Be very careful. Because let's say I set load game to, I'm about to set save game to 0. Can anybody guess what I just did? Or can anybody understand what I just did and how I completely just, made the universe implode? Main menu is 0. New game is 1. Load game is 2. Save game is 0. Delete game is 1. Exit game is 2. No! And this won't cause a compiler error.
I both like and hate that. I can kind of see why they did that way, but also that's just mental.
And again, the usefulness of assigning an enum value to a specific value isn't that widespread, because generally speaking, when you create an enum, you're really creating your own numbering system, your own set of valid numbers, and correlating them to integral values isn't. It is typical. It's something that a lot of people like to do, but it leads you down the same path as just using integers themselves. You wouldn't be getting the same benefits of enums by just not using the concept correctly. Now, again, that's not to say that I have never treated an enum like an integral value. And again, typically it's when I'm doing interoperability, interop programming, or the
Interoperability.
Yeah, but I'm not looking for that one. I'm looking for anyway. When I'm doing interop with other things, or working with other libraries, or working in maybe even a embedded context, I might use enum values as integers, but typically I don't. I avoid doing this because I think it really breaks the concept of what an enum should be.
Well, and also, yes, more so, you could quite simply swap over, say, lines 7 and 8 there, and you wouldn't break anything.
Right.
Your code will still function.
Yep.
You can't do that if you start assigning specific values to them.
Yep. Okay, do you have to create an enum type variable before using an enum? Could you not just say int current menu equals main menu? Yes, you can. And this code will work just as before. That's because enums have a implicit conversion from the enum to a integral value, but they do not have the other way around. So, for example, I can't say current menu equals 10. This would be an error, because there is no implicit conversion between an integral value and an enum type. But there is the other way around. However, if I were to type current menu as integer, I have just, again, disrespected enums, and I'm not using them in the appropriate manner.
And the phraseology of that question, actually, because you said, could you not just say int current? You're not actually doing any more, it's not doing any more work by typing it just directly to a menu state than it would be if you were using an int there.
Right.
I suppose you're doing slightly more typing, but that's the only extra outlay of effort.
Actually, in this case, it would be more appropriate to have
You
this
do
be a
auto,
char.
or, oh, yeah.
Well, an auto would turn it into a menu state.
Yeah.
A char would turn it into a just char.
Yeah, no, that's what I meant, actually. In this case, you've got main menu. It's specifically setting it to a menu state, so auto would be the way to go.
Is this the same as class and VB? Which version of VB are you talking about? Because if I recall, VB6 doesn't have classes. Oh, no. It does have classes, but it doesn't have inheritance. I can't remember. But no, enumerations are custom types, just like classes are custom types. But enumerations and classes are very, 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 very different. Would putting that enum into main use more memory, or is putting it before the function better programming? Okay, just to reiterate, this and this, this and this and this do not in any way consume memory in runtime. They are just compiler time constructs. They don't exist in runtime. The CPU has no concept of what an enum is. The compiler will literally turn this code into using, in this case, a char, because we've told the enum that its backing type needs to be a char, and then they'll turn all these references to these states into constant integral values, meaning that the enum definitions themselves do not consume any more or any less memory whatsoever. However, the variables that are typed to the enum do consume memory at runtime, and they'll consume as much memory at runtime as it takes to store the backing type for the enumeration. In this case, the backing type is a 4-byte wide integer. So this variable will take up 4 bytes. Any variable that's typed to menu state, however, will be backed by a character, which is a single byte integer value. So current menu will take up a single byte at runtime. And if I were to add, 2, 3, 4, 5, now I have 1, 2, 3, 4, 5 bytes of memory being consumed. If I were to delete it all, now I have 0 bytes of memory being consumed for the main menu state. And I wasn't trying to when I say things and I repeat them over and over again, I'm not being all fresher as why don't people just listen the first time? No, it's that these are really important concepts, and I'm glad people are asking questions, because otherwise we would have moved on considerably further, and then you wouldn't have derived any value from the class. So I'm not at all trying to act bitter, because this is really what we're here for. And if my tone of voice sounds bitter, it's really not. Because, again, this is important stuff.
I, on the other hand, give them something to do.
Yeah. Okay. I'm just going to...
Nuke it. Start again.
I'm just going to say, create a... blah, 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 blah. Month enum, create a season enum, create a function, takes in a month and returns the correct season value, create a function that takes in a season and returns the projected temperature. That's not how you spell it.
No.
Projected temperature for that season, make stuff up. And invoke the function 3 times with, invoke or write code that converts January into a temperature in main.
Temperature. Is the way to remember it.
Okay, do this.
And the seasons, which months go in which season? December, January, and February. You want to jot this down? Are winter. And you can work the rest out from there.
Alright, I'm going to go ahead and hit pause.
Stop and show us how to do it.
So, and we are back. So let's go ahead and look at how we would write this code. I'm going to go ahead and enter in a different project so that the code that I write isn't... Okay, so the first thing we would do is we start with an enum for the current month. So we would have Jan, Feb, March, April, May, June, July, August, September, November, December. And I don't know, you can break that out a little bit. Okay, and then I can go ahead and write... Oh, am I missing an October? I am missing an October, aren't I?
Indeed.
So then we can go ahead and write out a season enum. So we have spring. Wow.
Are you advertising again?
It's whenever I go to type out spring, I type in sprint. because I've typed in sprint.com so many times to pay my bill, and I've typed in spring almost never. So yeah, spring, summer, fall, winter. Okay, so the first function, we want a month to return a season. So we can say season, get season by month, month m, month. And I can go ahead and say switch month, and say case December, case January, case February, return winter. And then I can say case March, case April, case May, return spring. Then I can say case June, case July, case August, return fall. And then I can say case September, case October, case November, return failure. And then by default, we will return spring. I typically would throw an exception right here, but we haven't covered exception handling. And then maybe I could clean this up a little bit.
It's worth noting at this point that, because you actually, funnily enough, when you wrote it out for the previous class, you did actually do it the other way around. You left winter as the default and didn't do a December case, as I remember it. Or you did something along those lines.
Well, I'm just returning spring just to return a valid number. I would typically throw an exception. I would cause an error.
Yeah.
I would say invalid month specified and just blow up the program. Okay, so this is how we would get a season by a particular month. Now, to get a projected temperature, we could say get temp given a season. So I can say switch season, case spring, let's say it's 40, case summer, let's say that's 50, case fall, that's 40 again, and then case winter, that's 30.
See, Mr. Perlishells did ask why you aren't doing that return as the default case for the switch.
So why am I not like erasing this?
No. I mean, well, no. But why haven't you given the switch a default case?
It just seemed cleaner to do it this way.
Yeah, I was just asking.
That's it.
There's no. I thought it was a good point. Why? Yeah, you have.
There's no hidden reason why I didn't put a default. I just found this to be. I found this to read more for one specific reason, and that's this. The reason is, I think, in the back of my mind, why I intuitively did not go for a default when typing this code out was I feel that a default in this case carries the connotation that there's an appropriate default value, whereas there actually isn't, because this code, if you provide a month that doesn't correlate to any of these constants, you are wrong, and I would want to throw an exception and end the program. And I think that kind of in the back of my mind I was thinking, well, I'm not going to use default because I'm not saying that there's a valid default. I'm saying that there is no valid default. These are the only values you can specify.
That makes sense. And yes, pleased to see Zolkos say fall through looks pretty useful after all.
Why return spring? I would have thrown an exception if we've covered exceptions. I could return -1, but I would have to cast it to a month. Or sorry, cast it to a season. Because I'd have to cast it to a season because that's this. I honestly don't care what this return is. Because if I was writing this code, I would just throw an exception. Or if I was writing this code for my purposes. Okay, so now with this code written out, what we can do is we can say cout, get temp, get season, January.
Just Jan.
Right. And then I could say March. If I run this code, you'll see that we get 30 for winter and 40 for spring. So,
and you could equally obviously do in, C in or C out what, please enter a season.
yeah, stuff like that. But
Goes
this was less about user input and more about, yeah, this sort of stuff. Okay, so how does everybody feel about this code?
Nobody feels anything about this code. Streeter feels peachy. Hello, Miranda.
But
God, you've been quiet tonight. Pretty good, pretty good. Makes sense. Slow down! From someone. And Jables feels warm and fuzzy inside. That's good. So, do you just want to actually, is the one thing that I would ask you to clarify is break out one of either line 49 or 50 into what happens in what order rather than inlining it?
well, it looks something like...
Just to clarify that. Cool.
Sweet.
So there's no questions. What's next?
Structures. Hold on. Can an enum be made a non-built-in type like string instead of int? No, cannot. When you get stuck, if you do as a programmer, what do you do to solve the problem?
Break it down into bullet points, it would be my answer. Work out exactly what you're trying to do, step by step.
Right.
So that's partly why I asked Nelson to break that out, because it comes down to what happens first and what happens in which order. The first thing you need to know is, well, I'm going to need to get a month. Assuming I've got a month, I then need to get a season that relates to that month. How do I relate seasons to month? Okay, well, I'll use an enum and a switch. And then, so yeah, and literally bullet point it out. The way I tend to approach it is sort of give broad headings, and then each one of those narrow it down into like steps, and then each of those steps narrow that down into steps until you're literally writing very nearly, pseudocode, like Shinja says. Because when you get down to writing, what do I need to do? I need to get a season by, depending on the month. Well, that's the method that Nelson's called get season by month. You literally end up writing almost code. It's kind of like sneaking up on it from behind. What do you just write? If in doubt, start an interface.
Well, no, continuously just bang your head against the keyboard. I mean, obviously there are processes that are very helpful, like what Gavin just talked about, but even if following those processes you get stuck, just take your hand and move it over some keys and mash them until letters start coming out, and see if it compiles.
Is that why you don't want the letters on your forehead? You don't want them imprinted across your forehead? All the letters from your keyboard.
But no, it's. I mean, I don't mean that in the literal sense. Obviously, you have to have some direction of where you're going. But the idea is that you don't have. If you don't understand a concept, just write it and write it, and the code might work and probably won't. But when it does, there's an opportunity there for you to get a very good understanding. And for everything that doesn't work the way you'd expect it to, once it does work, you instantly have a much better understanding because you now have specific reasons why your first original attempts failed. If I'm using the technique of getting a month from the user, what's an elegant way to switch on the user input to send in the month, or switching on the input to send in the right month value the only way. I would write a method that something like month parse month that took in string input, and then I would switch on, or not switch, I would say if input equals January, or input equals Jan, or something like this. And I would probably end up using a map, like which is a data type similar to the dictionary in C#, to correlate input to the proper enumeration values. That would be the most straightforward way that I could see doing that. Okay, so let's talk about structures.
Let's talk about structs, baby. Let's talk about... You won't get that, you're too young. Thank you. Glad to see I'm not the only old person here. Yes, I should have sung it down here. It's a good track, that. I might have to go and dig that out on YouTube. Anyway, structs.
Okay.
What is a struct, Nelson?
Yes. I first want to say something really quickly. We are not talking about classes. If you know what a class is, for the purposes of this discussion, you do not know what a class is. Classes and object-oriented programming do not exist until week 7. Does everybody understand this? Because on Monday, I spent so much time explaining the differences between classes and structures and leaving so many people just scratching their heads saying, what's going on? I don't want that to happen again.
Well, it was because you were trying to explain the difference between structures and classes without actually explaining what classes are.
Yeah.
So, forget about classes.
So, no classes exist. We're talking about structures. We'll talk about classes in week 7. Okay. So, very commonly in programming, we encounter situations where we have multiple variables that are conceptually linked together. So, for example, I might have a string product1 name equals product1, and then a double product1 price equals this. And let's say I wanted to make a function to display a product. I wanted to call it display product. Well, what data does a product have? Well, it has a name and it has a price. So now we can say product name costs that. And so now I can say display product1 name, product1 price, and we get the behavior that we expect. This code it's not very good. And the reason it's not very good is because we have 2 bits of data, 2 variables that conceptually link together into the idea of a product. And even right here where we're taking in a string name and a double price, we're still really, we're just sort of grouping these bits of data together in a way that isn't necessarily that appropriate. Furthermore...
Well, yeah, and you're relying on the person who's calling the method to actually correctly themselves pass in the right name and the right price, and making sure that they pass in the price that goes with the right name. And
yeah. Like, for example, in our data model, because we do have a data model, our data model is we have a thing called a product, and it has a name and a price. That's our data model. Now, our data model isn't currently in any way being represented in code in a concise way, but it still exists. There's still a sort of abstract, little floating idea of this data model in our program. And what if in our data model we decided to add in a string notes? So we say string name, string notes, so our products have name and notes.
And go ahead and add at least another couple of products to main.
Okay, so I just added a new thing to our data model, but you'll notice now I have to edit a bunch of existing code in order for this change to be represented elsewhere. So for example, I would now have to say string product1 notes equals product1 notes. And now I have to say, well, what am I passing in? Product1 notes. So that refactoring was very obnoxious. And if we were to have many of these products, you would notice a sort of problem here. So now we have two products. Now you might be saying, well, this looks a whole lot like an array of things. And then you might be thinking, well, you know, I would really like to collect all this data on products into an array, but here's the problem. Arrays only store homogeneous data. An array cannot store a string in a double. It cannot store two strings in a double. It can only store either one thing of one type. So we run into a situation where to represent this code in an array, we would be forced to create 3 separate arrays, and we would still more or less be back to stage 1. Now the final reason why our data model is problematic in the way we implemented it is if I wanted to make a method called getProduct, okay, so if I were to create on line 10 a function that gets product information and returns it, what do I place right here? I can't place anything.
On a postcard?
Huh? There's nothing I can place right here right now. And here's why. We do have a data model. We have a product entity thing that exists in a very abstract sense in our code. And we represent it here 1, 2, 3 times in 3 separate sections of code. We have it in this parameter list, we have it in these function declarations and initializations, and we have it in this function invocation. We need a way to take bits of data and conceptually organize them. Now, fortunately, C++ and many other languages contain or have the ability to coalesce disparate pieces of data into one entity.
Or even disparate.
Disparate, that's the word. Yes, desperate.
Desperate pieces of data.
That data is
fantastic.
So yes, I meant disparate. Sorry about that. But you get my point. We need a way to bring these things together. Because right now, these things are not together. They're free-floating concepts that have no structure. What did I just say?
I don't know. I was still contemplating your screw-up on desperate, so I wasn't listening. Sorry, what did you just say?
I can't remember the exact wording at this point, but I said something along the lines of we need to organize these 3 different pieces of data into a single structure.
What could that possibly signify?
We're going to be using structs. What is a struct? Well, a struct is a user-defined data type. Very similar to enums. So for example, I can say struct product. Now notice some important things. I opened up with the struct keyword. I gave it an identifier, identifying it as a unique entity in my program. I opened up curlies and I terminated with a semi. This semi behaves the exact same way that enum semis work, and it is very important to have it there. So what goes in a struct? Well, data goes in a struct. So what we've done here is we've created the definition. We've actually like I said before, we did have a data model. Our program did have a data model, but it was an abstract sort of data model, free-floating, didn't have any structure. We've actually now described our data model to C++ using the built-in functionality of structures. So we've now instructed C++ that we want to have a thing called a product, and we want the thing called a product to be composed of 2 strings and a double. Now, composing these different pieces of data into a single data type provides us with a lot of benefits, but I do want to stress I really want to stress this, that this does not consume memory yet. This is a definition of a type. It's not executable code. It's not code that that is going to be executed during runtime. As in lines 5 through 10, this is not code that gets executed at runtime. No additional memory gets allocated. That being said, just like with enums, we can use this data type to create variables of this type and use them for parameters and return values, and for types and arrays that allow us to work with our data. So let's see how that looks like. Instead of these 3 different parameters, I can type in product. I can do product.name, product.notes, and product.price. My getProduct function can now just return a product. So now I can say product p, and I can say cout name, cin p.name, cout notes, cin p.notes, cout price, cin p.price, return p. Now right here, these lines can be replaced. I can do this in one of 2 ways. I can say product1, and then product1.name equals product1, product1.notes equals product1.notes, product1.price equals this. Alternatively, I can do product2 equals open curly product2 notes, and a price. So how do I use these 2 product objects with my display product function? Well, I simply pass in the products I want to display. So product1 and product2. And if I were to run this code, you'll see that our products get displayed. And then the console window immediately closes.
Sweet.
Okay, so what do we have? So should we put the structs in a .h to use them among multiple CPP files, just like an enum? Yes. A structure, again, is nothing that the linker cares about, but the compiler does. If you want a struct to be accessible from other CPP files, it's appropriate to place the definition of the structure into the corresponding H file, or whichever H file is most appropriate for this type. Can we have an array of structs? Yes, we can. We are leading up to that. Other than that, are there any questions? And come on. Does everybody just instantly understand what's going on here? Or not? Because it's fine if you don't. Because that's why I'm here.
But if you don't, we'll come over there and slap you.
Oh, well, Gav might, but I'll actually help.
I love it's this bizarre world that's occurred in the last few months. You've suddenly turned into the fluffy, caring one. These ponies are changing you.
Is there another name for the variables of a struct? Yes, these are called fields or attributes. The specific thing that they are fields, or member variables is another appropriate but less commonly used name. Typically, you'll refer to these as fields. Now, the field that I have name, notes, and price is the literal language feature that I'm using to represent this data. The abstract notion of a product having a name is called an attribute of that product. So if you were talking in terms of UML, you would refer to name as an attribute. You wouldn't refer to it as a field necessarily, because a field is a specific way to express an attribute in C++. Whereas an attribute is a more generalized conceptual meaning of this object has this attribute, this piece of data that it carries around with it.
Is the word property usable in C++
No.
in any way, shape, or form?
Kind of. Maybe, sort of. We'll get to that in week 7.
Yeah, I wasn't sure.
There are no properties in C++, but
Right.
you could...
Because I was just thinking because like in normal English, these are the properties of the product.
Mm-hmm.
It has these properties. That's what makes it a product. And I just wondered if that held.
If you say the word property in C++, people are going to assume that you're referring to method pairs, like a get blah and a set blah method.
Okay.
Why does it get defined as product?
It's just he's chosen to call his product.
Yes. Because this is a parameter to a function, and a parameter to a function has 2 bits of data associated with it. It has the type and the name. The type in this case is product, which must be a valid defined type, at least as of line 12. But the name can be anything.
But the name product could equally be Gerald. Just because you don't know how to spell Gerald.
You just want to see me try to spell Gerald. It's probably why you've said it so many times.
I don't know. It's a pleasing word to say.
Gerald.
Like moist. And spherical. Anyway. You get the point. The product with a capital P here is the type.
Can you elaborate a bit more on how much memory that ends up taking up? Yes. Every instance of this structure will take up, at the very least, and typically... Now, here's the thing. Just like with stack frames, the C++ compiler gets to choose how much data it allocates for the structure. Now, once we talk about more advanced features of C++ object-oriented programming, I will be pointing out a little bit more data that the C++ compiler makes available for objects. But the C++ compiler will at the very least provide enough data to store all of the fields that we define. So it'll at least store, how many bytes is a string typically? 32 bytes or something like that? And then a double is going to be 4 bytes. So, or 8, sorry. So, yeah. It's going to be very close to however much data is required for all of the fields within a structure. What type
of variables can we mix in a stack? Anything you like, really.
Yeah. Characters, strings, vectors, arrays, other structures.
Whatever value types you feel, or whatever types you feel you need to... yeah, I was thinking that direction as well.
That will...
Make something else, like a...
Well, I mean, if I made an enum inventory
sale
status...
item. Or, yeah. And that immediately also points out a very nice bonus with structs that's similar to the sort of added value you get with enums in terms of the amount of work that you have to do.
So now
simply by adding that there to your definition,
right?
You've added functionality to a product.
Yes.
You've added, yeah.
This inventory status is now available to each one of my functions. So now I can say if status equals in stock, cout in stock, So by doing that, I've instantly added an additional piece of data that's going to be passed around with every product variable. Can you initialize the fields? We're not going to be talking about field initializers here, because that introduces complexity and some considerations that we're going to have to talk about. The answer is yes, kind of. When using the second version of filling a struct with values, do you have to declare the variables in the same line? Not in the same line, but in the same order. So you'll notice that I can do this if I wanted to. It would look a little bit uglier. Well, depending on how big these string literals are. But they have to correlate to the order of the fields of the structure. So I have to say this turns into the name, this turns into the notes, and this turns into the price. But if I were to swap the price or the name with the notes, now this is going to the notes, this is going to the name, and that's going to the price. So the order is significant when working with structure initializers. Oh, right. You won't be able to initialize a structure using this syntax unless you are defining and initializing the structure on the same line. So, for example, I can't do product1, and then I can't do product1 equals blah, whoa, blah. You'll notice I get a nice little compiler error saying that expected an expression, which is, this is a typical C++ error message. It's not saying, so we're sorry, you can't use struct initializers on lines that aren't declaring the variable. Instead, it says expected an expression.
How very helpful of it.
Yeah. When you create or use a struct, do you have to fill in each field, or can you leave some empty? Sure. The fields are going to be initialized to their default values. So for numeric types, that's going to be, or no, sorry, they're not going to be initialized. Derp, I had a C# moment. The fields are not going to be initialized to anything but garbage. For basic types, that being said, strings will get initialized properly. So they're not going to be garbage. But these guys won't get initialized to anything other than garbage. What happens in the second? Well, yeah, if I didn't put in a status field in here for the initializer, so my field variable is going to be a bunch of garbage. So if I were to set a breakpoint right here and run this, you'll notice that I get, open up product 2, you notice that I get a in stock, which might, hold on.
That be as it,
There we go. That's what I expected to see. The only reason I hadn't done this before, because I've never done a structure initializer without specifying every field, because that is kind of nasty. In this case, I wouldn't take advantage of any built-in default behavior in this sense. I would always specify every field, especially for cleanliness. Are strings initialized because a constructor is called yes, but that's a class? Well, it's also a structure. Ah, words. How would a struct affect a bubble sort? It would not affect a bubble sort. A bubble sort would be appropriate to use with structs.
it would be no more inappropriate to use with structs than anything else.
Yeah.
Would be a better way of putting that.
Okay, arrays of structures. Arrays of structures, very straightforward. Products 10. For int I equals 0, I smaller than 10, I plus plus, products I equals get product. And then display products is going to be the reciprocal. I'm actually going to bring this down to 3 so that...
Yes, so you don't have to write 10 examples.
Right, and then I'm going to go ahead, and I'm going to leave the inventory status being garbage. It doesn't matter. Actually, I'm just going to go ahead and set it.
You could just nuke the status.
Okay, so running this code, it's going to fill up the array of structures just like you would expect. There's really no difference between using an array of structures here than if you were to use built-in types. So I can pass in every standard thing, and I completely messed up because because I'm not using Getline. I probably should just change the code to use Getline, so excuse me for 1 second.
No.
Yes. Hey, I'm the one with the keyboard.
Yeah. If only you knew how to use it.
Okay, so I'm going to go ahead and say name product 1 notes product 1 notes price blah.
Dun, dun, dun.
Yeah, I think C# or C++ just hates me.
Hurrah.
So yeah. Now this array, when main gets initialized or when main gets invoked and the stack frame is initialized, the amount of memory required to store 3 products comes with that stack frame. So an array of 3 products is going to be the size of product times 3 as far as how many bytes it's going to consume. Are there any questions about arrays of structs? There's not a whole lot more complicated than normal arrays. They're just structure arrays. Everybody feeling super awesome about them? Can size of be used with a struct? Yes. You can say cout size of product. And I get 80, so it's 80 bytes. Can a struct hold an array? Yes, a struct can hold an array, but I kind of want to avoid talking about that until we get into pointers. Although you can have a static array of a specified amount in a structure that is legal, but it gets more complicated later down the line. Is there a way to pass in or return an array without using pointers? No. Nope. And we'll be talking about that next week.
Did you answer that question already?
Which one?
The one that I've been flashing at you for the last 5 minutes.
Yes, I did. I said, yes, strings are initialized because of a constructor is called, but a constructor is something that you should not know about because today is not.
Oh, right,
Yeah.
okay. That would be why I didn't remember the answer then. Because the answer was, I'm not going to answer.
Well, I did answer it is, but yeah, words. Okay, I guess everybody's so good with arrays of structures.
Cool. What's next?
Vectors.
Well, actually, what's the recording time at the moment?
We're at 1 hour 40 minutes.
Cool.
Okay, let's just quickly introduce vectors, and then after that we're just talking about input and output. Then we're done. Okay, what is a vector? In C++, a vector is a type provided to you by the STL, and the STL is a component of the standard C++ namespace. Now, the closest comparison to other languages would be that a vector is a list in C#, and I believe a list also in Java, or are they called array lists in Java? I can't remember. But it is essentially, for those of you who are not familiar with other languages, a dynamically sizable array. It's an array of values that's dynamically sizable.
It has nothing at all whatsoever to do with what a vector actually is, was, and always shall be, and has been for the last 8,000 years.
True. It's not an XYZ coordinate, or an XY coordinate, or an X coordinate. It's literally a resizable array. And just like arrays, it has a few qualities to it. First quality is it must store homogeneous data, meaning you must define the type of data that the vector is capable of storing, and any data that you add to it must conform to that type. The way it's implemented behind the scenes is that a vector will contain a reference to a dynamically allocated array. And as it needs more data, it will delete the old array, create a new array that's larger, and copy in the values from the old array to the new array. I got the order of that kind of mixed up, but the point is a vector is a wrapper around a dynamically sizable array. But it gives us a really, really nice interface for accessing this sort of data. Okay, let's quickly talk about vectors. To declare a vector, we type in the word vector. Vector is a class, and it's accessible here because we have the using namespace std import at the top of our file. Vector is a part of the std namespace. Now what follows on a vector will look really funky to people. Not to C# people or Java people, but it'll look funky to people who might have been coming from dynamic languages or who are new to programming altogether. Basically, a vector is a templated class. It's a generic class. And we have to provide it, when working with a vector, we have to provide it a type. And that's the type that the vector is going to store. So let's say we want a vector of integers. We would open up this angle bracket, type in the word int, and then close the angle bracket. At this point, our vector type definition is complete.
And you'd read that as vector of type int.
Yes, or just vector.
That's vector of int.
Yeah, vector of int. So at this point, the type is done, and we can now give our variable a name. Numbers. So now let's do something fun with it. I'm going to go ahead and write a little program that's going to say int input cin input cin.ignore if input equals 0, then I'm going to break. If input is not equal to 0, then I'm going to say numbers.pushBackInput. Now, the pushback method, it is a method because numbers is an object, is going to send this bit of data to the end of the list. And if the vector does not have enough memory allocated to store this additional member, it will transparently, behind the scenes, establish more memory from the operating system to actually hold the data we told it to.
And it's it's pushing to the back. It's not pushing back, like pushing back against something. I mean, for anyone, if in C# this would be numbers.add.
Yes.
It works in exactly the same way. And your first reaction on seeing pushback, if you're used to that, is, well, that's a stupid name for things. But it's doing exactly what it says. It's pushing, i.e. adding something to it at the back of the list.
Yep. Okay, so let's say we wanted to iterate over everything in this list and we wanted to find, I don't know, let's find the average of all the numbers typed in. So I'm going to say int sum equals 0. I'm going to say, now this is where things get fun. For auto I equals numbers.begin, I does not equal numbers.end, I plus plus, sum plus equals star I, and then I can say double average equals sum divided by numbers dot size. I can say cout the average is average. So now when I run this program,
Now,
you what?
will you get integer division?
Yes, I believe I would.
So, you failed.
This isn't pointers. We're not using pointers. I just want to point that out. So push, can you use a non-built-in type for a vector like string? Yes, we will be talking about that very shortly. So pushbacks adds data to the end of the vector. Yes. Okay. There's three things that I've represented how to do here. We can push.
Huh? I was going to say, if that's not a pointer, what is it? That asterisk.
It's an operator that has been overloaded on this data type. It's also an operator that's used for pointers, but we're not using it in that context here.
That's cool. Just as he'd asked, I thought you should mention that.
Okay, so I'm showing how to do three things here. Pushing back to a vector. So adding data to the end of the vector. Number one, very important thing. Number two, iterating over every item within the vector. This is where things get a little funky. Now, every STL container, so every container under the STL banner, and mostly every container even outside of the STL library, there's really a convention of how to iterate over a container. And the convention is to use an iterator object. You access the iterator object for numbers via the begin and end methods. The begin method returns an iterator that is pointing to the beginning of the vector. The end method returns an iterator that is pointing one element after the end of the vector. So to loop over everything in the vector, we say for auto I equals vector.begin, I does not equal vector.end, and then I++. The plus operator, the postfix increment operator, is going to be overloaded on the vector object and going to actually perform some computation, moving the vector forward. Finally,
so is that actually
what?
Is that actually that I++ essentially doing the same as I plus equals I times size of the value type of the size of it?
Well, kind of to an extent. Iterators are actual objects that can be used even in cases where the data isn't actually stored in an array. So like maybe like a linked list, you could still use an iterator. It doesn't necessarily correlate with contiguous blocks of memory.
Right, okay.
Then finally, to access the current item that we're looking at, we use the star unary operator, or the, what is this called again? The dereferencing operator. And the dereferencing operator is being overloaded for this particular iterator type to provide the current value that we're sitting on. Now, this is something that I will be doing. I will be using the begin and ends methods and the iterators. But I do want to point out that this isn't the only way to loop over a vector. A vector provides what's called an indexer. So for example, I could have just as easily said this. Vectors provide an index operator just like arrays do.
See, that's just like C# in that form.
Yes. This...
So why wouldn't you use that form?
Because, well, first of all, not all containers are accessible by index, such as linked lists. And in that sense, the cleanest way to do it is to iterate over things by using the iterator. In addition, you can do fun stuff with iterators. Basically, think of an iterator in C++ like an IEnumerable in C#.
Okay.
Meaning, that's how you would implement link-style functionality in C++ is via iterators. They provide a lot more functionality. Now, you'll notice I've been using implicit typing. The explicit typing of this is actually going to look like this. So after seeing this, you should understand why I would use implicit typing for that case.
Because, yes, you can have things like a vector of vectors of ints.
Yeah.
And I've seen that in code.
Okay, so the next thing that I'm demonstrating here is how to index a vector Now again, not all containers are indexable, but you can do it with vectors. And the final thing I'm showing here is how to get the amount of elements inside the vector, and that's via the size method.
Stephen brought up a point which actually I meant to at the time. You said at the beginning of this discussion on vectors, you said that vectors are included in the standard namespace, but he's getting an error unless he includes vector.
Yes. When I say that vectors are inside the standard namespace, you still have to include the vector header. Because if you look at
you didn't actually say that today.
Well, I typed in vector. I said you had to include vector. Vector is under the STD namespace. You'll notice if you open up the vector header itself, everything inside this header is defined in the namespace STD. Meaning, by including vector, it adds additional items to the STD namespace. See, if I were to delete include string and include vector, right now the only thing inside the STD namespace that we can access is the stuff in IOStream. If I wasn't to include string, now we've added the string type to the STD namespace. If I was to include vector, we have now added the vector to the STD namespace for this file.
Yeah.
But even if vector isn't included, it still is in the STD namespace, but you still need the header to access it.
But yeah, sorry, just because, like I say, that came up and it was obviously breaking what he was doing.
So is a vector compiled if it's dynamic? A vector isn't dynamic in regards to typing. A vector is a static type. However, it dynamically allocates memory at runtime. There's a very, very, very important distinction. C++ is not and does not in any way natively allow you to represent dynamically typed code. C++ is entirely a statically typed language, meaning vector is compiled in its entirety when the program is compiled, and the code that goes with the vector object gets compiled into your executable file. It's not dynamically compiled at all. But during runtime, the vector objects may ask the operating system for additional memory to store the data that you ask it to.
And I would
Does that make
personally
sense?
say, is coming at it at the 101 level, that is just not something that you desperately need to panic if you don't understand it. All that happens behind the scenes.
Well, we're going to be talking about dynamic memory allocation next week.
Oh yes, this is one of the benefits of using the vector type, which is that it makes it easier to do these things. It essentially does them for you.
Yes.
Otherwise, you would be limited. In the old days, you would have been limited to doing what it's doing, which is, if you want to add an item to an array, you've got to create a new array that's bigger by one item and copy the stuff across and delete the old array. It's still doing that, but you just don't have to.
Yeah, you don't have to do it yourself. Okay.
Does vector add elements like a stack or a buffer?
Buffer. It adds it to the end.
Yeah, I did see in BuzzNet he was asking, is it FIFO or Philo?
Oh, it's well, there's no in and out into a vector.
Yeah.
It's not like a queue or a stack, which have specific methods for pushing and popping, and enqueuing and dequeuing. A vector is just an array. That's all it is. So, if you were to use the pushback method repeatedly and then loop over the array, you would receive your items back in first in, first out order.
But equally, if you were to do pushbacks and then do a reverse for loop, then you would get them in first in, last out.
Right. So if you did R begin and R end, you get them backwards.
Numbers.rend.
Okay.
Do you want to change that back before it bites you later?
Yeah. Okay.
You're going, why is this doing this?
Is I does not equal numbers n at the same as I is smaller than numbers n in your example? No. No, in fact, I don't even know if this has an implemented operator.
You sounded really peeved about the fact that the answer was no there. You're like, no.
Well, actually, I'm getting similar behavior. Oh, I'm getting similar behavior because I was doing it again correctly. No, I'm still getting similar behavior.
I was going to say it should be, surely. I mean, it should behave that way in this case.
It's not. It must be. Again, this is actually something I've never done. I've never done this before. The reason I've never done this before is that the end method returns an iterator that is pointing to not the last item in the list, but the item after the last item in the list. So it makes more sense to say while I does not equal end than it does to say while I is smaller than end. So there's no difference to my knowledge, and there very well might be. It's just nothing I've tried to do before. I've always used the inequality operator with vectors. I've never used the other equality operators, or the other whatever they're called, operators. Just like an array with functionally implemented to manage sizing when needed. Yes, that's all a list is, or that's all a vector is. A vector is just an array that magically allocates more memory for you behind the scenes.
Andrew, your question, I would like to award you a big bag of cookies for. I wish more people would think this way. I really do. He asked, push back the init set are all methods of a vector. Are there more, and how would I find them out? Key question, this, and something you should always really keep in the back of your mind the first few times you use something you've not used before. Go ahead and show him how to get the...
Just type in numbers dot, or of course look in the documentation, but you can immediately see all the methods that you have. We have some fun methods. We have like the at method, which is a nice little method that provides bounds checking for your vector. You have, what else do we have? The capacity method for checking to see how much memory the vector is allocated to hold your data. We have the clear method for clearing everything out. We have the data method for retrieving retrieving a constant pointer to the data stored in the vector. We have the empty method, which returns a boolean if the vector is empty. We have the erase method, which is used to erase items, but it's a little bit more complicated than you'd expect. Well,
you've got to give them points for really trying to make those as unfriendly messages as possible. Look at the state of that arrays tooltip.
No, it's quite simple.
How is that helpful?
It's an std vector of int and std allocator of int, iterator, and it's a method. I was trying to be facetious, but this is going to take too long.
Kind of my point. There's the friendly, this erases everything from a file.
Okay, so then we have other methods, pop back to remove the last item from the array or from the vector, resize to force it to allocate more or less memory to store its data, shrink to fit.
I like shrink to fit. That's rather cool.
Yeah, to get it, because the vector will generally end up allocating a little bit more memory than it needs to at the moment, so that it doesn't have to allocate memory on every time you add something to it. In fact, it doubles the amount of memory it internally allocates every time it reaches the capacity. And then you have a bunch of these guys, which, typically speaking, always ignore the underscore methods.
Now Zolkos brings up a kind of... That isn't quite what I was getting at. Those tooltips just say the arguments, they don't say anything about what the methods do. That's a contradiction in terms. The arguments and the return type, if it's programmed properly, should tell you what the method does, pretty much. It's just that it doesn't in plain English. like in C# in the C# version, it would give you a nice description that they've written telling you exactly what it does.
Yeah.
But any method, any function you should be able to get a general sense of what it does by looking at the return type and the arguments that you're passing in.
Yep. Okay. And then Scorp actually sums it up in a really...
And the
in
name,
the name,
as
yes.
Mr. Wu points out.
Scorp actually points out something that's stated more eloquently than what I said earlier. And he's saying I is representing an iterator of the vector type, and not literally an integral counter, so it's not reliable to compare the two different types other than to say is equal to or is not equal to. Because remember, there are more collections in C++ that do not store your data in a contiguous fashion. How does performance of a vector compare to an array? Well, the performance of a vector is going to be generally very good compared to an array. There's very little overhead when using a vector compared to an array. The only time you are going to run into any significant performance penalties when using a vector is when the vector is forced to resize itself because you're trying to stuff more data into it than it's capable of handling. However, those cases are minimized due to the fact that the vector, for every time it reaches its max capacity, it'll double its max capacity. If you're using a vector to store a lot of data, the amount of times that it has to reallocate itself exponentially diminishes. So they are perfectly performant, fine things to do. If I use an iterator instead of just using the regular I, how do I access I plus 1? You can actually increment, to my knowledge, you can iterate using the addition operator. So I can say I plus 1.
No, he means like if you're doing the bubble sort where you need where you loop over each one.
You wouldn't use an iterator for that. If you're doing bubble sort with a vector, don't use an iterator, use the indexes directly. Otherwise you will confuse yourself very, very quickly. It's very non-obvious the way iterators work in relation to next items and previous items and when it comes to swapping. Although, if I'm not mistaken, never mind. Okay. Hi, you said that I is not a pointer. But isn't the I plus 1 known as pointer arithmetic? Is it the same as iterating through the elements of an array by defining a pointer? No. I is not a pointer. I is an object. The plus plus operator is being what's called overloaded. Just how our bit shift operators are being overloaded with cout. These are the
people might not have picked up on that because they won't have come across bit shifting necessarily.
Okay. Well, this is an arithmetic operator. This is for doing bit shifting. However, the cout object is of type OStream, and the OStream type overloads the behavior of this bitwise operator. I can't do this bitwise operator on an object that doesn't know what it means. So, for example, I can't say numbers 2, and here's why. The vector does not overload this bit shift operator. It does not define any functionality to happen when the bit shift operator is applied to it. So in much the same way, over here on line 68, we increment the iterator. This isn't doing any pointer arithmetic. It will be doing pointer arithmetic behind the scenes, but not necessarily depending on what type of container you're using. This is not doing pointer arithmetic right there. This is simply saying, iterator, I know you have special functionality when I apply the postfix increment operator. I'm going to go ahead and apply the postfix increment operator on you, and then you can pick up from there and actually perform your internal logic. The same thing happens with this star. The star is an overloaded operator. Now, yes, in the case of a pointer, this would dereference the pointer. In the case of this being a pointer, this would increment the pointer. But because they're overloaded, it's not necessarily true.
The clearest example you'd have seen of operator overloading would be string concatenation.
Well, yeah, how you can't do it.
Hey plus, well, okay, can you, oh, I hate C++. All right, in proper languages where you can do string let equals hey plus,
Or even.
well, even I was going to do hey plus there, yeah, but, and you'd want a space, but that should make it clear what's going on though, because that is in no way, you know, there's no logic saying hey plus woe. It's hey and woe, but we're using the plus operator as just saying this is a convenient symbol to use.
Right.
It means roughly that. But, you know, we're not doing a mathematical operation with that plus. We're just using it as a shorthand.
Well, I mean, this, yeah.
Or yeah. We're defining
This would,
it to
well,
mean
that example
something
actually,
else.
I didn't know that's where you're going with it. This example doesn't compile.
Yes,
because it thinks we're doing arithmetic. But if I were to say this, that would compile because the plus equals operator is overloaded for strings.
Oh, God, what a stupid language.
Okay, so moving on. Can you?
I hope that that should make it a bit clearer.
Yeah. Can you repeat what you just said about using vectors with bubble sort? Yes, if you're bubble sorting a vector, don't use the iterator syntax because that would be confusing right now. Just use the normal array indexing operations, or not the array indexing operations. Just like how we said before, vector overloads the indexer. The indexer being the symbol, for example, this is the indexer operator. A vector overloads this and provides similar functionality to an array.
Was it? It would have been the open hours where we went, where you actually did the whole bubble sort in code.
Which
it wasn't
means
Monday's class, was it?
Yeah, which means that it's uploaded and available.
Yeah. So go and well, no, because we spent about half an hour, as I remember.
Yeah.
Covering in detail what it did in what order. So that is there now because Wednesdays. The one just gone.
The asterisk before this iterator asks the iterator to return the current value that the iterator is sitting on. So for example, if we run this code, oh, right.
Will it break if you take that asterisk out?
Yes.
Or will it?
Oh, great.
I wanted it to show the
C++ is being smart and realizing that this is an iterator, so it's automatically dereferencing it in the debugger. But if I were to take this off, I get an error. I could say it says no operator append matches these operands. Why? Because this is an iterator. This is not an integer, this is an iterator. I believe there's a method on it that gets the current item. Maybe not. But notice all these operators. All of these operators are overloaded on this iterator. So the most important one is going to be, right now, the dereferencing operator. And the dereferencing operator, we simply do that. That's going to return the current integer that we're looking at.
This is a dereferencing, which is almost the exact opposite of pointer. Kind of conceptually, to me. Or dereferencing.
It's like saying a number at I. Yes, it is. But we can't do that here because our I isn't an integer. It's an iterator object.
We are kind of just, there's a certain amount of we are just stuck with this slight awkwardness in C++, and you just have to get used to it because, like Nelson says, it is something you'll find yourself doing quite a bit.
Okay, so it's about time for another quick break, and then after that we're going to be talking about, we're going to roll in the discussion of vectors of structs with file input and output, and we should have some fun with that. So I'm going to go ahead and pause the video. Zooming. Okay, so we've talked about
Structs.
Chris,
We
yes,
talked about vectors.
but we'll see that. We talked about structs, vectors, enumerations, and yeah, let's talk about file input and output. So, file and input and output is actually not terribly difficult in C++. The header that you need for the standard file input-output libraries is, not surprisingly, fstream. Once you have the fstream include, you get access to the input and output file types that will allow you to, well, input and output to a file. So, let's talk about printing to a file first. To print to a text file, and we're only going to be talking about text files here, we use the OFStream type, or output file stream, and I'm going to call this FOUT. And people should notice right off the bat that FOUT looks very similar to another object that we use quite frequently, and yes, it behaves in almost the exact same way. So the first thing we're going to need to do is we're going to need to open up the stream. So that's going to be the fout or ofstream.open method. The open method takes in a string literal or a string class or type object, and it allows us to open up a file relative to where our working directory is. So if I opened up a file called products.txt, I now have that file open. Now I can check to see if the file is not open by doing not fout. So basically, that's going to check to see if we successfully opened up the stream or not. Now to print text to the stream, not surprisingly, we do hello like hello world, a string literal. The OFStream object will behave just like the OStream object, which is cout. And it provides pretty much the same methods and the same operators as you are going to expect. So very, very straightforward concept.
So if products.txt doesn't exist, that you will hit lines 56 and 57, yes?
No. The default of actually we should never hit this unless there's a problem with the file system. Maybe we don't have permission to open this file.
That's what was slightly. So I was looking at that going, well, when presumably that must be. But I thought, huh? That was literally my thought process.
Yeah. Yes, we have to declare an OFStream object in order to interact with the file, because this is the object that we're going to use to write text or any other kind of data to a file, OFStream. And so you'll notice that we can use the similar operator to cout. So this is printing to the console, this is printing to a file. Now we can name our OFStream whatever we want. We can call it file, we can call it file output, we can call it products file, whatever we want. I personally like calling it fout because of the similarities it has with cout. So typically I will do it this way. Once we're done printing out to the file, what we need to do is we need to make sure to close it. And to close it, not surprisingly, we use the close method. Now what does closing exactly do? When we open up an OFStream or a file stream of any sort, we ask the operating system for a file handle. We say, operating system, I know you have a file right here, or maybe you don't, maybe you do, whatever, but I want permission to be able to write to it. So you ask the operating system for a file handle. Then when you're done writing to the file, you must give that handle back. Otherwise, that handle is not going to be cleared up until your program terminates. In addition, the fout object, or the OFStream object, will buffer the text or any data that you send into it. It'll buffer it into an internal buffer. It might not necessarily print the data that you passed into it until you close it or until you flush it. But flushing manually is more or less pointless unless you know exactly what you're doing, because you would want to leave when to flush up to the OFStream object. You wouldn't want to do that manually unless, like I said, you were doing something very specific. Typically, you would just leave it up to it.
And there's one thing that I just want to clarify, unless I've majorly misunderstood. But because you said straight out the gate that we're just talking about text file handling here.
Mm-hmm.
But that is nothing to do with the fact that on line 52 you specified the name as being products.text.
Yeah, yeah. This could be...
That could equally well be .ini, it could be it could be anything. The fout is going to treat it as if it's a text file.
Mm-hmm.
So you know.
So it's going to convert a number, for
If
example.
in actual fact it's a doc file, you're going to end up with garbage. If it's an XLS file, you're going to end up with garbage with recognizable bits in it. Because it will treat whatever input it gets there as if it was receiving. Because, can you explain about how it's stored? You know where I'm going with this now.
Well, yeah, no, it's going to encode it.
Than I am.
It's going to encode it into ASCII. So if we sent in the number 42, it's not going to print out the literal bytes 42. It's going to convert it into its corresponding ASCII codes and then print it to the file stream. And the extension is irrelevant. Extensions don't mean anything in Windows. Extensions are only used as a convention so that Windows knows which program to open up your file with when you double-click on it, and what icon to give the file. What happens if you don't close the file object? If you don't close the file object, the file handle is not going to be released until the program terminates. And potentially the buffer is not going to be released. So the internal buffer of our OF stream is not going to be sent to the file unless we close it. Now, that's not necessarily true. It might print out the buffer. It might not. However, you should explicitly always close your streams, because if you don't, you are locking up native resources on your computer until your program terminates.
It's like staying in a parking space after your time has run out. You're taking up that space without actually utilizing it.
Yeah, and it will be released once your program terminates. When your program terminates, Windows will be like, well, fine, you didn't give it back, I'll just take it back for you.
Get off my memory.
Yeah, but while your program is running, it'll keep the handle open until you close it. Does it create a new file if one doesn't exist? Yes, this will create a new file if it doesn't exist. Where does it look for products.txt? I'll change this back to products.txt.
Good question, that.
Where does the app look for it? It looks for inside the current working directory. The current working directory, every application has a working directory. Every application has a directory in which every file input and output, or every file reference, is relative to. So this is going to be the current working directory. Now, when I run this, we're going to notice a very interesting caveat of how Visual C++ deals with working directories.
And particularly for C#.
Yeah, which is slightly different.
C# take special notice of this.
Yep. How can you specify directory? Creating and managing directories is out of scope because it's a little bit more complex than you'd expect. But to specify a directory, if the directory already exists, we could say dir/products.txt. But that's out of scope for the moment because directory handling is a little bit more complicated. Okay, so when I hit F5 and run it, it created this file and it dumped this text into it and it wrote the buffer. Now, where did it put the products.txt? That's the question.
See, Bando's come across exactly what what we're about to go through. He said, I looked in the debug folder where the exe got built and do not see that file.
Oh, well, that's from Monday. That's from Monday.
Yeah.
I was freaking out. I was like, wait a sec, where did that come from? Okay, your first instinct would be, oh, well, working directory is probably the directory that the executable is in. Let me jump into the directory that the executable is in, and oh, wow, there is no products.txt file. My code's broken. Actually, when running your code inside of Visual C++, the working directory gets set to the directory of the project, which means we have a products.txt adjacent to our VCXproj file. Our VCXproj is what describes this project to Visual C++. And then there's our main file too. So our working directory, when working under Visual C++ is going to be where the project is located. Now you'll notice something interesting. If I jump back into the debug folder and double click on this executable from within Explorer, you'll notice a products.txt got created next to the executable. That's because by default, the working directory is always going to be wherever you executed the executable from. So if I open up products.txt, not surprisingly, you see the words hello world. Are there any more questions about basic file output?
Or at least what we've covered of it. Do you just want to give a rundown of anything else of brief interest that's available on fout?
Yeah, it gets complicated.
I didn't know if there's any odd ones in there that you just go, look, it's got this, look, it's got that.
Just treat it like cout and you'll be fine for now. Okay.
So, how do we get that information back again?
Well, you do so with the IF stream, not surprisingly, input file stream. Do you use /n to move to the next line? Yes, you do. And I do want to point this out really quickly. If I enter a /n and run this program and jump into the file, actually I'm going to print this multiple lines. Now when I run this and jump into the file, you'll notice people who are familiar with line endings might be slightly confused. You'll notice that this renders correctly in Notepad. That's because we are on Windows, and because we're on Windows, the fout object will correctly convert the /n character to the appropriate environment-specific line ending of Windows, which actually isn't /n, it's /r/n, or a carriage return followed by a new line. So in actual fact, there are two characters at the end of each one of these lines, a /r character and a /n character. But the standard library correctly identifies that we are running on Windows, and as a result, appropriately fills in the correct line endings.
And I'd just like to point out that that is a really stupid way of handling things that Windows has.
Yes.
In what way do you just have a carriage return? A carriage return is a new line. It's the same thing.
Yep.
Anyway, end of sidebar.
Okay, so file input. File input, very straightforward. IF stream for file input stream. Can anybody guess what I'm going to call this object?
Gerald.
No.
Oh.
Yep. I'm going to call this object fin. fin stands for file in, just like cin stands for console in. So, does it need to be called fin? No, I just like it to be. Okay, so how do we work with an input stream? Well, fin.open products.txt. Sweet. How do we read in from an input stream? Now this is where things get fun. First of all, I'm going to say fin.close. You must close all your streams, so I'm going to put that in first. And now I'm going to go ahead and write a bit of logic. I'm going to say while fin.peak does not equal ifstream traits type EOF method. So, what is this while loop doing? This while loop is saying, while the next character is not an end of file character, continue executing the while loop.
And an end of file character is... I can't believe how silly this sentence is going to sound. An end of file character, it is just like a new line, but for the file. It signifies that you've reached the end of the file. Yes. Did that sound really dumb?
Yes. But there's not much other way you can...
You know why I said it.
There's no other way to represent
that
statement.
If you see EOF, it's end of file.
File names are not case sensitive, correct? On Windows, file names are not case sensitive. On Unix operating systems, such as Linux and Mac OS, file names are case sensitive.
And you really shouldn't assume case insensitivity
if you're working with cross-platform code.
Just on principle, yeah.
In the situation of not successfully getting our file output stream, what does Windows do when we return 1 instead of 0? And does that error check work the same way with ifstream objects? Yes, this error check also works with ifstream objects. I could also say this. If not fin, can't open products, return 1. Windows doesn't do anything special with the return 1. It's just there to signify that the program didn't exit correctly. Okay, so the method peek reads in the next character. That's important. A file stream, or conceptually a stream of any kind, does not know when it's going to end until it ends. So the fn.peek method will read in the next character from the file, but it won't remove it from its internal buffer, meaning if I were to ask for more data, I would get what was peeked first. And then I check to see that that next character is not an EOF character. So now what I can do is I can read in data, just like we do with cin. So I can do something like string line, getline. Now remember the getline function? It's important that the getline function does take in an iStream, because a cin object is an iStream as well as an fin object, or ifstream is an iStream. Meaning,
Wow.
words.
Say that again.
We can pass in fin and line. And then we can say cout, and I can go ahead and I'm going to add an int line counter equals 0. And I'm going to say blah line counter plus plus blah line. So now you see that I retrieve 3 lines from the file, those same 3 lines that I printed out. 4 lines.
Wow.
I saw 3 there and I got confuzzled.
Yeah, no, I realized that. That was just like, wow.
Okay.
There are...
What? Hello?
Whoa. Hello? Jason?
Jason's freaking out. I think he exploded.
Has he got some sort of decibel cutout on the audio? I don't know.
Jason?
Yes?
Oh, did you say something?
No.
Okay. Anyway, okay. I like Bando.
Well,
Anyway,
Bando got it.
oh, that's what you said?
Yeah.
Okay.
What?
Okay, so...
What? No, sorry, I need to know. What on earth are you talking about? How nothing? There are 4 lights compared to... What? Which is all I heard you say.
I can't help that you're English.
Oh, don't start on that one.
Oh, it says, Gavin, you should be ashamed.
Hey, I could be asleep right now.
Okay, so... Yes, we have successfully read in data from a file. Is everybody comfortable with this code?
No.
Besides you. Okay. So let's quickly talk about how we can save and load a list of products. What is traits type? Traits are a very interesting feature / abuse of template metaprogramming in C++ that isn't really that appropriate to be discussing at the moment. They're actually really...
That said...
They're a really cool little thing, but for right now, take it for granted that the way you get the proper EOF character is by specifying ifstream, traits type, and EOF.
And actually, yeah, I think I said on Monday, this is a bit like learning how to write a formal letter or anything like that. It's one of those things where you just need to take it as read, but this is what you do for now.
Mm-hmm. Okay, so line gets treated as one long string. No, the getline function is going to retrieve a single line from the iStream that we pass in, and the iStream we're passing in is fin instead of sin, and then it's going to assign that entire line to the line variable. And then I'm going to immediately turn around and print it out. And each line is, of course, delineated by a new line character, or in the case of Windows, a carriage return followed by a new line.
And yeah, it's worth pointing out that, because the only reason we're able to do that while loop in that way is because we've specified that each thing is coming back on its own separate line. Yes?
Yep.
Yes.
Is there a limit to length apart from memory? No. No limit to length of a line, apart from memory, of course.
But your input and output here can become as convoluted as you want or need it to in terms of how it writes things to file and reads things back from file.
Sure.
It's just a question of making sure that your pairing pairs up. I mean, if anyone's done any work with X and A, for instance, you've got pairs of essentially parsers for different types of file. And it's just in doing your own, it's just a question of making sure that the thing that you write, you read back in the same order and in the same way.
Yep. All right, let's talk about saving a list of products.
Oh, there was another question came in. Is there a limit to line length apart from memory?
I answered that, and I said no.
Oh, did you?
Yes.
Sorry.
Well, apart from memory and how far integers or unsigned integers can index. Okay, so let's go ahead and talk about reading to and writing from a file with in regards to a vector of products. So the first thing I would do is make a vector of products called inventory. I'm going to say product P1 equals product 1 notes 23.3 in stock. And then, of course, let's do 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, whoops, 3, 4. And then I'm just going to say 1.3, 2.3, 3.3, 4.3. This one's going to be on back order, and this one's going to be out of stock. Okay, then if I were to add them to the inventory, I could do inventory.pushback P1, P2, P3, P4. And we now have a vector of products. So how would we save this to a file? Well, the first thing we need is an OF stream. And I'm going to open it up, open products.txt. And I'm going to say for auto I equals inventory.begin. I does not equal inventory.end I plus plus. Product equals star I. Then I'm going to say fout product.name, new line. Product.notes, new line. Product.price, new line. And finally, I'm going to cast our product.status to an integer. And then I'm going to finish it off with a new line.
And why are you casting it to an int?
Because otherwise it doesn't save it. You don't have, or never mind, it does. What? Yes. Certain situations of printing enums are going to fail because enums don't necessarily have an implicit cast to an integer. So typically, to avoid confusion in other bits of code where this might not be possible, I will by default cast my enums into an integer for storage reasons.
Cool. And yeah, it's because obviously this is just for storage purposes, so it doesn't need to be human readable.
Yeah. Somebody asks, why does the auto break in their Mac OS? The Mac OS version that you're using, even the latest version of GCC on Mac OS, does not support implicit typing, so you'd have to write this out the longhand. Longhand, it would be vector of product : iterator. This is the longhand version of this type. which it might be clear now why I like using implicit typing for cases.
You made him a sad panda.
I'm sorry. Okay, so then I'm going to go ahead and say fout.close. I'm going to run this program. And now if I jump into our products.txt, you'll notice our products got saved. Sweet. So how do we load them back into a vector? Well, what I'm going to do is I'm going to take this code and I'm going to move this into a function. I'm going to say void save products takes in a vector of product called products, or sorry, inventory sounds better, and then a string file name. So this code is now its own function.
And the last thing he did there, for anyone who happened to blink at the time, was copied the file name into line 62.
Okay, so I just made a nice little function out of it. And of course, this is incorrect. Now it's correct.
Score paid. Fantastic.
Okay, so now let's write another function that will load products. I'm going to write a function that returns a vector of product called load products and takes in a string file name. So how is this function going to work? Well, the first thing, we need a vector of products. Next thing is we need ifstream, an input stream. I'm going to call it fin, and I'm going to open it up to file name. Then I'm going to say while fin.peak does not equal ifstream traits type EOF. Now what goes in here is going to be interesting. The first thing I'm going to do is I'm going to declare a temporary product to load our data in. Then I'm going to say fin getline fin temp dot name getline temp dot nodes. Now what goes next is going to be very interesting. The first thing I'm going to go ahead and do is I'm going to say fin temp dot price. Then I'm going to say fin dot ignore because I want to ignore the new line that's going to be placed at the end of price. Then I'm going to say fin temp dot status, which isn't going to work because it doesn't know how to read this in. So instead I'm going to say int temp status. I'm going to read it in int temp status, and then I'm going to say temp dot status equals inventory status temp status.
And yeah, we did have a question on why are you not using Getline for the float? And this is, you haven't actually done it in detail. This is something that you've kind of done before and explained as you were going, but haven't focused on.
Right. Well, temp.price is going to be a double. So if you look at the definition of this field, it's a double. A double is not a string. Therefore, you can't use the getline method or function with the double, with a type of double variable, because the getline function only works with strings. And because it only works with strings, there's no way that we can use it with doubles. So as a result, you'll notice I use getline to get the string data, and then I use the normal extraction operator to grab the price data. Okay, so then I finish this method off by push backing the temporary product we constructed during every iteration of the while loop, and then I return the inventory that we constructed. So now if I was to go ahead and say vector of product inventory2 equals load products, products.txt, now I can say for auto I equals inventory2.begin, I does not equal inventory2.end, I++. Then I could say display product at I, display product dereference I. The purpose of using this temporary status is that we cannot extract from fn directly into our status field. We can't do that because fn doesn't have any concept of our inventory status enumeration. So instead, I'm extracting the integer value, and then I'm converting the integer value into a product or an inventory status enum. Does that make sense? Sweet.
Yeah.
Okay. When I run this program, you'll notice we get all of the data back from our file. So what we did was we constructed an inventory, we saved it to a file, and then we immediately turned around and loaded it. So now if I were to, for example, comment out this code completely and collapse it. So now the only bit of code that we have is us loading products from products.txt and then us looping over the loaded products. When I hit run, you'll notice we get our product inventory back, even though we didn't specify it in our own program.
Hurrah!
So yeah, this is an example of using file input and output with vectors using custom structures that have enums inside of them.
And really, with a little bit of thought and not a lot more complexity, you can do an astonishing range of things with this, from, you know, configuration files for a program to well, pretty much anything that you can serialize into text form. You've got the ability to save and load now.
Yep.
So while this has been, you know, like people have said, that, you know, there's been a lot we've covered a lot of little things this week. But now here, where we put them all together, hopefully you can see how useful this can be in sort of non-trivial circumstances.
Mm-hmm.
That was thought for the day.
So is the file a line separated value? Yeah. It's a new line separate. All the values are new line separated, just for ease of explanation. Okay, so how's everybody feeling about today's class? Now is the time for questions regarding anything that we've covered here.
Shiny.
How do you loop through a vector if you wanted to bubble sort it? Since you suggest that we use the indexer to dereference values inside the vector when bubble sorting. Yes, if you're going to be bubble sorting a vector, instead of using iterators, I would recommend to just use a loop. So for unsigned int I equals 0, I smaller than inventory 2 dot count or size, sorry, I plus plus. Now I can say product left equals, well actually it would be inventory 2 size minus 1, inventory 2 at I, and then product right equals inventory 2 at I plus 1. That's how I would loop through. And the reason I'm using an unsigned integer here is because the size method returns an unsigned integer. Actually, more specifically, it returns a vector of product size type. So if you wanted to get all fancy, you could do that. Which, this is just an alias for an unsigned integer. This looks big and messy. Can we just not read from and write to a struct all at once? Oh, well, you kind of can. You kind of can for binary values, but even then, think about it this way.
Well, actually, maybe if you're answering this question would be, when would it be appropriate to do this sort of string saving for data as opposed, text saving for data as opposed to, say, a binary file?
Well, that gets a little bit more complicated. I would typically want to use binary files because they're faster to parse and typically smaller. and generally make it so people don't try to go in and muck with them. But as far as reading and writing a structure all at once, could you answer this question? How much data does this structure contain? And I don't mean literally. Well, okay, let me rephrase
You
the
mean
question.
can one answer this question? Is it possible to answer the question, how much data does that contain?
No. How much, when I say none yet, those are all appropriate answers just because I pointed to this, and this by default doesn't store any data. But let's talk about this. How much memory does this ultimately use up? The answer is you can't know, and here's why. The string data type allocates memory dynamically, meaning that this product structure, although the product structure is known at compile time how big it is, the data that we care about, we don't know at compile time how big it is. We can't take the memory layout of this product structure and dump it into a file. That's impossible. Because if we were to, what we would get is we would get our string objects containing references to memory that might have been allocated during one execution of your program, but would not be allocated during another execution of your program. So at the very least, while you can just simply dump an entire structure into a binary stream, if it doesn't contain any dynamically allocated memory, if it does contain dynamically allocated memory, then you will have to do more work. And there's no way around that. Yes, the structure would have to be of a fixed length. And if the structure was of a fixed length, which actually I should rephrase that because structures are per definition fixed length, but conceptually the fact is, although this is a fixed length, the data we care about is being stored elsewhere, namely the name and notes strings. And as a result, it makes just dumping it down into a file impossible. Now there are libraries and there are ways, fancy ways to get data serialization to be really nice and straightforward, but those require language features that we haven't yet discussed, essentially.
We did have someone just asking if you could go
the
over begin and end again briefly.
Yeah. Okay. Every container in the STL, so every object in the standard template library that contains data, such as the vector class, has the concept of an iterator. And an iterator is another object that represents a pointer, not a C++ pointer, but a literal pointer or a bookmark into at what point of the sequence that it's looking at the moment. The begin method returns an iterator that is pointing to or looking at or has bookmarked the beginning of the vector or the first element of the vector. The end method returns an iterator that has bookmarked or is pointing to the element immediately after the end of the vector, which is an invalid element. The end iterator will signal to our program when we need to stop iterating. Otherwise, we'd be iterating into empty space. The increment operator is overloaded on the iterator object. The iterator object has a special bit of functionality that is invoked when you increment it. Now, when you increment an integer, you just get one bigger. Your integer gets incremented. If it was 0, it becomes 1. If it was 1, it becomes 2, and so on. However, this increment operator has special meaning and executes special code hidden behind our iterator object. And what that code is going to, in effect, do is make the iterator position itself one more item in advance of the collection. The last bit about the iterator, the most important aspect of what an iterator allows. Okay, so when you do does not equal end, how does it know it's at the end if it doesn't equal the end? The end method returns an entirely new iterator. And we're comparing our left iterator with our right iterator. And
left and right in terms of the not equals operator.
yeah. So the end, remember, the end points to an invalid item. And we're basically saying, while our iterator does not equal an iterator that is invalid, then continue to loop. So we don't want to continue looping if our iterator points to an invalid element. Now, we do want to loop if our item points to the item before the invalid element. We want our loop to continue even if we're pointing at the last element, but we want it to stop the second it gets past the last element. And the final bit about the iterator is the dereferencing operator. This is a special operator that's overloaded that returns the current item we're pointing at. Which, again, someone else pointed this out earlier, the plus plus and the dereferencing looks suspiciously similar to pointer arithmetic and pointer dereferencing, but they are not. Although they are similar in what happens, they are not conceptually the same concept of what's going on here.
And sadly, there's a good reason why they've chosen those operators to overload, because they make a sort of conceptual sense.
Yeah.
In the same way as the plus does with the strings. But that in itself is confusing when you're learning this stuff because, like you say, it looks like pointer arithmetic.
Right.
So and because pointers are one of those C++ buzzwords, it's the sort of thing you've heard of even if you haven't got the first clue. I'm speaking from experience here. you know what pointers exist before you know what they are and what they do.
Right. It's always the looming sort of thing, along with object-oriented programming. So never call pushback in the for loop because you'll never hit the end of the vector. Yeah, pretty much. that would be not ideal. In Gavin's words.
Suboptimal. So any more questions on, well, today's class, really? Before we throw a huge, evil homework assignment at you that will take you years to do.
Build me a video game. 3D game.
Make me a make MMO button.
Yeah. Alright, it looks like people are pretty much ready for this.
Did have someone say, can you scroll up, please? Cool. So, homework.
Okay, homework. Okay, is that good?
Beautiful.
Sweet. Basically, the homework is going to be to...
You can go look at the thread.
Yeah, I have the thread up there, actually. Basically, what we're going to be doing, and I'll try to leave the rest of the code in view for people reading. Basically, what you're going to be doing is reworking the project that you've been working on so far. Basically, we want a product structure to contain a name, price, and description. We want to allow for 0 to many products to be added by the user, so think vectors. Every time a product is added, print all the products to a file. Every time the program is started, read all the files from a file. And continue to make sure that everything is sortable. So in main, have a basic state machine using Enum, similar to what we showed in class, for a main menu that allows you to add a new product, sort products, display products, and exit the program. I did make one stipulation, though, because the state machine code can get a little bit verbose. So I did say that the function main has no line limit. But that's not an excuse to place functionality in main that should be elsewhere. All other functions must obey the same line limit as previously. And remember, this is an overly generous line limit. Line limits are really important because people should really be thinking in terms of how to get their code footprint down on a per function basis. So I really want to
And I mean,
stress that.
if you look at what Nelson's got up code-wise, not so much the last the bits, but I mean, if you can look at all these functions, 10 lines-ish each.
Yeah.
Not even that if you actually do what constitutes a line, but, you know, 10 numbered lines in your IDE. Because, like we said, we are rubbing this in, I know, but it's an important central concept. They're doing one thing, and really, if you start to get above, what did we say the line limit was? I think it was 40 lines. Yeah. 40 lines, you can do a lot in 40 lines.
Mm-hmm. Yes, you can create a vector of structs, just like what I had right here. A vector of product.
In fact, I was trying to think, but I couldn't off the top of my head think of one. Although he's just now saying, right, these are what structs are, and this is how we make structs. We've been using built-in, come up with a built-in struct that we've used.
We've been using a lot of built-in classes.
Yeah, I know, but the classes don't exist, remember?
Right. I don't know if anything we've been using is a struct.
But the concept still stands.
Yeah.
Remind me to finish that sentence when we do classes, and then I will finish it. But no, essentially, just because you're making these yourself, and this applies to a lot of the questions that have come in along the lines of, can we do such and such in a struct? Can we use vectors in a struct? Can we use structs in a vector? Can we use strings in a giraffe? Yes, generally speaking, apart from the giraffe thing, that you might have problems with the RSPCA. Say what I'm trying to say, please.
Yeah, well, yeah, stuff and things.
Just because you're making this product type, it's still a type in the same way that something else is a type.
Right. Okay. When we print into the file, it's going to append to stuff that's already there. It's going to overwrite everything. So every time you add to a product to a file, have it overwrite the entire file and reprint out everything. It looks like the homework does not need the buying portion of the program, just product management. It would be fun to put the buying portion into the program, but as I was writing out the prompt, the user interface might get a little bit too complex and get away from the points that I was trying to make with the program. So it's not needed, but it would be a fun thing to do if you wanted to. Okay.
And remember also, for those of you who struggle with time and real life and such, this homework thread has been up and linked to, and it will continue to be the same each week. It's been linked to from the live class calendar from the since the end of Monday's class. This has been, so many of you, I imagine, will have already seen this. Is what the homework's about. But so next week, from Monday, the homework will be up if you want to get a head start. And, you know, push yourselves. Don't rely on, because we are, you know, this is the homeworks are getting incrementally. We're adding stuff. Mm-hmm. So it's not a question of a huge chunk of things. You could conceivably do the next week's homework based on this week's knowledge for the most part, and a little bit of research. Just saying.
No.
And we have had some questions come in now, though.
Is overriding the default functionality of opening a file stream and writing to it? Yes. That is the default functionality. Is there a way to nicely copy a project and rename it in Visual Studio?
Well, is there?
I don't know. Let's try it.
And that's a good question because it can be a pain sometimes. As you can see, the short answer is no. But you know what? You now have the skills to write an app that would do this for you. Pretty much.
Oh, come on. I just associated slins with Notepad.
Nice. You just broke your everything.
There you go. Rename the file. And that's how you do it.
Rename the file. As if that's all you've done. Yeah, Chris, I will send you a PM about that. Although probably not this morning, because it's now 4:45 here. And I'm flagging. The sun's coming up, the birds will be tweeting in a minute.
I hate that noise. Reminds me that I've been up too late. Okay, so any more questions? Because we're about to head off.
Jason, are you there? Have you got anything to add?
No.
Okay. Well, that concludes week something
5
of C++ 101. And see you all later.